So hey folks, welcome back to another video. This is the second video of NLP playlist series, and we have the terminologies guide and terminologies for this video. And before jumping to the any specific topic of the NLP, I want you to be very clear with the terminologies that you will encounter in the NLP series. But don't worry, we will discuss those terminologies in a very detailed manner when we encounter the particular topic of the question, right? But for now, you just have to be very familiar with the terminologies, not the expert of the terminologies, right? So start with the basics, that is foundation. First we will go for the tokenization, right? Tokenizations is kind of similar to token, right? When you remove the tokenization, because it is a process, right? When you have a token, you will instantly connect the dot of a token with the model's subscription, right? That you have heard of, that Claude has used 3.6 million or 4.8 million tokens in their AI code base and whatever, so far, right? So token is essentially a particular word, right? So for the definition, tokenization is a process of breaking down a text or a string into a particular pieces, right? Like a words, subtokens, or a characters, right? So if we take an example of I love AI, okay, as a text, so we can break those three the sentence into three words, that is essentially I and love and AI, right? So these particular words, that is I love and AI, are the tokens, right? And you can instantly connect that dot. And then we have a vocabulary. Suppose you're training your model to learn the learn the words, but you will find that there are tons of words, right? You cannot feed particularly every word into the model. So what you do, you essentially took only those words, essentially the unique set of words that are called unique set of token, to feed to your model and let that learn. So that particular unique set of tokens is essentially known as vocabulary, right? In your data set has words like a hello and world, so your vocabulary size will be 2. If you are training your model to be only 2 words essentially, that is hello and world, since both are different, unique, so we will have that 2 as a vocabulary of the entire model that you've been training, right? Then where you will find encounter, where you will be found vocabulary to be using, right? You will found in a core problem, that is out of vocabulary, or in the embeddings, right? So we will discuss that, but you should be very clear with the definition for now, right? Then we have corpus. If we take all the tokens, then it will become the corpus, right? A large structured set of texts that is particular training that is particularly used in a training. So corpus can be understood as a let's say you have a data, right, where you have 2 columns, where first column is the text, that is review of your movie or your restaurant, and other column is the review, the sentiment, that is positive or negative. So essentially the collection of those reviews is called a corpus, okay? And that particular review is called as a document, okay? And that particular document, particular word is your token, right? Then we have data augmentation. Data augmentation you will heard when you have lack of resources, lack of data, right? You have to create data from your own data. That is the process of data augmentation, right? You will use that word, use augmentation as a creation of your data, like you have some words, so how you will generate more words? You can essentially create a sentence with a different sentence by just replacing the vocabulary. Like if you have a I am amazing, right? You can convert that sentence to I am great, and essentially now you have 2 different set of training data, right? So that's called data augmentation, right? Then we have morphology. Morphology deals with the forms of word, right? What it does, it either if we have many techniques in morphology, but it is essentially the study of structure in the form of words, where you convert particular word to another word by adding or removing the prefixes, suffixes, right? Then we have semantic. Semantic is the study of meaning, right? You will often heard a lot of people saying that my model fails to capture the semantic meaning. That means my model fails to understand the true essence, true understanding the text or जो भी था data, right? And you will see the famous example that whether your model can understand the difference between river bank and money bank. Here you are using bank as a same word, but here it comes in a different context, so you have to make those models that can capture the semantic meaning, that context of the meaning, right? So that is semantic meaning. Then we have pragmatic, that is understanding meaning behind the behind or a context in the real world application, right? Knowledge. If somebody says I'm cold in here, the paramedic means please close the window. Like paramedic can relate it with a sarcasm, that human can understand the sarcasm, but can model understand the sarcasm? Or the better example would be idioms. We as a human can understand the idioms, but can computers understand the idioms? Like if we say piece of cake, it is like we can do that, but computer will be like the actual piece of a cake. So this is pragmatic, right? Pragmatic. Then we have stop words. Stop words are those words which do not have the actual meaning and that do not contribute to the meaning of a sentence. If you remove those words, you can essentially get the meaning of a sentence, a word. So those words should be removed, and you will seeing me removing those stop words in near future, right? Example is am, are, for, okay, that is helping verbs, other things like the pronoun, noun, I don't know, but yeah, those like this, that, in, right? Then we have stemming and lemmatization. I have covered the long video on stemming and lemmatization, you can check out, but for now, lemmatization and stemmatization are the process where you convert a word to its root form, either whether if you do with removing suffixes and prefixes, like changing the es to e or s to es, right? Those is stemming. And if you convert the word to its root form, that is ran to run, that is lemmatization, right? And we will discuss those near future, don't worry. Then we have n-grams. N-grams is the continuous sequence of n words. Like I love NLP is a sentence, then I love and love NLP is a continuous sequence, that is will call be n-grams, okay? Then we have vectors and understanding numeric representation. Then we have first bag of words. Bag of word is essentially the technique that how you decide how you convert your raw text as a number so that models can understand, right? So we have a lot of techniques, but I want you to just understand the definition, right? A sparse vector representation of a frequency of word in a document. You got my point. Okay, then we have TF-IDF, that is term frequency, inverse term frequency, that weights how important word in a particular document. It essentially gives you the rareness of the document to the how frequent it occurs in the document, right? Then we have other word embedding techniques, that is essentially for the essentially related to the deep learning, like word to pack and globe, that gives the word surrounding according to the contextual words surrounding by the words, particular word. Like if you do king minus man plus woman, then you will roughly get to the queen vector, right? So okay, we will discuss those in very detail, don't worry. Then we have syntax and structural grammar, that is post tagging, that is part of speech tagging, where we tag every word in a sentence to its grammatically definition, right? Identification, what the particular word is, either it is a noun or a verb, whether it is a adjective or preposition, like that, right? Then we have name entity recognition, that is the extracting real world entities from the word from in a particular sentence. Like if we have the Elon Musk lives in Texas, then we can assign the Elon Musk as a name, lives is a location, oh sorry, Texas is the location, and yeah, this is the name entity recognition. Then we have dependency parsing, which essentially analyze the grammatical analysis of the word, like how they are grammatically related. These are different, but these are kind of similar, so we have to learn, right? Then we have advanced concept like model architecture, that attention mechanism, that technique that allows model to emphasize on a particular sentence. Like if you have the word turn off the light, you essentially don't need the knowledge of all the words to translate that this sentence to a to translate this sentence word. Like if you want to translate the word light to Hindi and you have a sentence turn off the light, you don't need other words than light, right? So this is the attention mechanism which focuses on this light word rather than this context words, right? Then we have transformer, the ultimate ultimate backbone of the NLP and other thing, and that you will surprised to know that ChatGPT full form, that is T, is a transformer, right? Then we have BERT, that is developed by the Google's bidirectional encoder representation transformer. And there is also a, I have not mentioned, but there is another one, that is encoder decoder before transformers, so add that into the document of your mind, right? Then we have evaluation, how we will evaluate, that we have perplexity and blue score. Perplexity basically means that how much our models get confused, surprised, right? And blue scores means that how better it can understand, how good it understand our data, or मतलब कितना समझ पाया है, right? Then we have what are the problems, that is bias हो सकता है AI में. Suppose that you give all the negative reviews and asking the model to give the classify that particular review to the positive or neutral. Like what? Nothing. Out of vocabulary, like if you provided if you didn't provide a sufficient large enough of vocabulary size, and you ask him to generate the next word, and which is not in the training vocabulary size, then it will false out, and that is the problem of out of vocabulary, right? Then we have hallucination, where models hallucinates a lot. You will see this in LLMs, RAGs, okay? Then we have classical machine learning for the NLP, that is naive Bayes, SVM, support vector machine, the backbone, the the hidden Markovnikov's model, okay? Then we have deep learning. I will not cover this right now because it eventually get scared you, right? So we have RNNs, we have LSTMs, we have GRUs, we have vanishing gradient problems, we have back propagation through time, that is BPT, obviously, right? Then we have sequence to sequence. That sequence to sequence is essentially the transformers and encoder together, right? So this was the brief overview of the terminologies that you will encounter so far. So if you found me very speed, so please set the video into the 0.5x or so. But yeah, this was the video. I'll see you in the next video. Bye for now.